Now we want to start looking at how we solve circular functions. So for example, if we've got an equation like cos x equals minus, we'll keep it positive, equals root 3 on 2. And we're solving for x is an element of 0 to 2 pi. Okay, so we'll start with something fairly simple. Alright, so with this type of thing, when we're solving circular functions, what we're doing is we've been given the y value and we've been asked to find the corresponding x values that will satisfy that equation. So cos x equals root 3 on 2. Well, the first thing I like to do is a little sketch so I know what I'm dealing with. Cos x, we know the graph looks like this. Root 3 on 2, we know is approximately 0.9, so it's quite high up, and we're going to have a horizontal line that runs through the graph, somewhere up there, just so that you know exactly what you're dealing with. Okay, so when we sketch that graph, we know that we've got one period, so it's only going to 2 pi, and we know that there are going to be two solutions, and we can see that the two solutions are going to be in the first and fourth quadrant. So it's really important to visualise what you're dealing with. Okay, so cos x equals root 3 on 2. Just like we had questions that we're asking ourselves when we're finding exact values, we have to have questions that we have to ask ourselves when we're finding solutions to circular functions. Okay, so what are the questions we're going to be asking ourselves? We kind of have to go in the reverse order. Just like when you're solving an equation, you undo it. When we find the solution here, we have to ask the questions sort of in the reverse order. So the first question I'm going to ask myself is, what angle gives me that answer from the table of exact values? So you've got to consider your exact values. Then you're going to ask yourself, well, which quadrants would I be in? And then, finally, what are the angles? Where am I around the unit circle? So that's unit circle. Alright, let's see how that plays out. Okay, so cos x equals root 3 on 2. First question I ask myself is, cos of what equals root 3 on 2? So if you need to, look at your table of exact values, but hopefully by now you've memorised it. Cos of what equals root 3 on 2? Well, cos of pi on 6 equals root 3 on 2. So the first thing you do is you identify what your basic angle is, or your reference angle, or your base angle. I'm just going to call it basic angle. Basic angle is pi on 6, because cos of pi on 6 equals root 3 on 2. Now, Vika would give you 1 mark just for identifying that basic angle. And you can call it base angle, or basic angle, or reference angle, or first quadrant angle. It doesn't really matter as long as you've identified what the correct angle is. Now you need to finish up the question by finding the appropriate solutions. So now you consider the sign of that y value. Root 3 on 2 is positive. So in which quadrants is cos positive? That's the first and the fourth. So I know I'm dealing with the first and the fourth. So, if you want to, you can do something like that so you don't forget which quadrants you're in. So we know we need the angles of symmetry with pi on 6 that are in the first and the fourth quadrants. So we know that x is going to be equal to, well, in the first quadrant it's pi on 6, and in the fourth quadrant the angle of symmetry, the one that's close to the x-axis, is 11 pi on 6. And you can back that up by looking at the graph. So I'll just start a new one. If we're looking at cos x, and I'm not going to worry about zooming in or anything like that, we're doing root 3 on 2, and I might need to zoom in because it's a bit hard to see, so I'm going to just look from 0 to 2 pi and then do a zoom fit. Okay, so you can see we've got this angle up here which is really close to the y-axis, that one there, and the other one over here in the fourth quadrant. So if you want to find the point of intersection, Analyze graph, point of intersection. Okay, when you find the point of intersection, you can't get them in exact values. I don't think that will allow me to change it. I'll try it anyway. We know that it's pi on 6. Will it change it? No. You can't change, it'll change the x but not the y. But we remember that root 3 on 2 was approximately 0.9. Well, there it is, 0.866. So that's your first quadrant solution, and the fourth quadrant one was right over near the 2 pi end of the period, and it's at 11 pi on 6. So when you use point on, you can change your value and it will give you the y coordinate in an exact form if it happens to be exact. But when you use point of intersection, it's not going to change the y, only the x. Okay, so let's do another one. Okay, let's do a negative one. What about sine x equals minus 1 on root 2, and we're solving, we'll keep it simple to begin with, solving for x as an element of 0 to 2 pi. Okay, so the questions we have to ask ourselves are, sine of what equals 1 on root 2, then which quadrants are we in, and then find our angles of symmetry. So a quick sketch so we know what we're dealing with. Minus 1 on root 2 we know is approximately a minus 0.7, so down here, and we can see straight away that our solutions are going to be in the third and fourth quadrant. Once again, there's two solutions. So let's do the algebra. The first thing we do is ignore the sign and ask ourselves, sine of what equals 1 on root 2? Well, our basic angle is pi on 4. There's your first mark. Then we need to identify which quadrants we're in. Well, the negative, sine is negative, tells us that we're in the third and fourth quadrants. So now we need the angles of symmetry. So if we're dealing with the pi on 4s, from your unit circle, the ones that are the angles of symmetry with pi on 4 are the 5 pi on 4 and the 7 pi on 4. 5 pi on 4 and 7 pi on 4. And you can see that corresponds with the graph. Okay, so these are pretty easy ones, but obviously they're going to be slightly more complex when you're dealing with them in an exam setting. Okay, you're not going to get something as easy as that. You might have a different domain, or perhaps some kind of dilation from y, so there might be more solutions or less solutions. So let's do another one. What about, 2 sine x equals plus 1 equals 0, for x is an element of 0 to 4 pi. Actually, let's complicate it further and put a 2 there. Okay, don't be put off by that. A quick sketch so you know what you're dealing with. So it's a good chance to practice your sketching as well. When we sketch a graph, we need to know the period. Now, when there's been a dilation from y, that's going to impact on the period. So the period is 2 pi over the coefficient of x, which is 2. So the period is pi. So we're going to have one cycle between 0 and pi. So sketch one cycle, that's pi. And we need to have, in this case, 4 cycles because we're going all the way to 4 pi. So lots of solutions here, so lots of chance to practice all your skills. Now let's undo the equation. So we know 2 sine 2x equals minus 1 and sine 2x equals minus 1/2. So that's the line that we're intersecting with. Minus 1/2 is down here. So we can see that there are going to be 8 solutions. 2, 4, 6, 8. Okay, so now we're ready to start. First question we ask ourselves, ignoring the negative, we do sine of what equals half. So sine of pi on 6. So our basic angle is pi on 6. Okay, which quadrants are we in? Sine is negative in the third and fourth quadrants. So we need our angles of symmetry with pi on 6 in the third and fourth quadrants. So 2x equals, well in the third it's 7 pi on 6, and in the fourth it's 11 pi on 6. So undoing that now, we get 7 pi on 12 and 11 pi on 12. So we've got our first two solutions, here and here. And now to get the rest of the solutions, we just need to keep adding the period to those solutions until we've got to the edge of the domain. So 7 pi on 6, add a period. 11 pi on 12, add a period. Okay, so the 7 pi on 6 plus a period is going to give us this one. And the 11 pi on 12, do I keep saying 6? Ignore me when I'm saying 6, it should be 12. Gives us the fourth solution. Then we need to keep going from there, so we need to keep adding periods to those solutions. So I might just tidy those up first. So we've got 7 plus 12 and 11 plus 12. Now we need to keep adding because we've got 4 more, so we need to add the period to each of those two solutions. So 19 pi on 12 plus pi and 23 pi on 12. Now in an exam you'd never be asked to find this many solutions because it's very repetitive. So the 19 pi on 12 was this third solution, so adding the period will give us the fifth, and from 23 pi on 12 adding the period will give us the sixth. And I'm not going to finish it off because I think you can just add the fractions and continue to do that. So check with your calculator and go to a calculator page. So we want to solve, it was 2 sine 2x plus 1 equals 0, comma x. And remember, with circular functions you need to restrict the domain. So we're going from 0 is less than or equal to x is less than or equal to 4 pi. Yes, I am, but I'll stop now.